Alright, so today we are going to talk about solubility and net ionic equations. Ionic equations are equations showing us the splitting of ionic bonds to form products in double replacement reactions. Our ionic bonds are held together by bonds. However, when we put them into water, they are dissociating or splitting from one another. This happens when we dissolve things. When we add table salt to water, you can see this ion dissociation or dissolving. Our sodium chloride as a solid is held together by the bonds. However, when we add in our water, the water comes in and surrounds each individual ion, splitting them apart. So our sodium, with its positive 1 charge, because it still loses its electron, is now surrounded by our water molecules, isolating it from the chlorine ion that has also been surrounded by the water molecules. Chlorine is going to keep its negative 1 charge because it kept the electron. This is what happens when we dissolve something. Solubility rules tell us when we are going to have a precipitate, which is a solid that forms from our double replacement reaction, or if we are going to have a soluble or aqueous compound. So on this side, with our soluble compounds, these are going to be shown as aqueous. On this side, with our insoluble compounds, these will be shown as solids. Pause the video in order to pull this up. It is found in your reference tables on our course website. You are going to want to familiarize yourself with this enough or keep it up while you work through problems so that it will help you predict your products. The splitting, or the ability to dissolve, shows us solubility. Solubility is the ability of a substance to be able to dissolve in a liquid, not just water. The substance that is being dissolved or dissociated is our solvent, while the liquid is going to be our solvent. For our sodium chloride example, the salt, or sodium chloride, is our solute, while the water is the solvent. Not all solvents have to be water. However, water is one of the most common solvents and is also nicknamed the universal solvent. A complete ionic equation shows all of the dissolved and precipitated compounds in our equation. For example, we have silver 1 nitrate and table salt. Just by being given the names of these two compounds, we can create a complete ionic equation and a net ionic equation. We will work on the net ionic equations next. To create our complete ionic equation, we first have to identify what the chemical equation is. We know that we have silver, which is Ag. The charge is going to be positive 1, and we have it bound with nitrate. Using our list of polyatomic ions, we know that nitrate has a -1 charge. -1 plus +1 gives us an overall charge of 0. And to this, we are adding table salt, which is sodium chloride. This was from our previous examples. We also know that it is balanced because sodium is a representative element with a +1 charge, and chlorine is a representative element with a -1 charge. Now that we have our compounds identified, we need to note if they are soluble or insoluble. By looking at our solubility rules, we know that silver nitrate will create a soluble compound, and sodium chloride will create a soluble compound. Therefore, they are both given that subscript AQ to denote that they are an aqueous solution. Now we need to predict products. We know that this is a double replacement reaction. Therefore, silver is going to combine with chlorine. Again, the charge on silver is +1. The charge on chlorine is -1. So they are completely happy like this. Our sodium is going to bond with nitrate. Sodium has a +1. Nitrate has a -1. They are happy as well. Now that we have our products, we will look at our solubility rules to make sure that we have identified any solids and any aqueous. Silver 1 chloride is going to be our precipitate, so it will be solid. And sodium nitrate will give us an aqueous, or a soluble compound. That was the first step. Now we need to write out our complete ionic equation. When we are showing this, we are showing each part of the compounds in their ion form because they are dissolved. Our silver has been dissolved from our nitrate. Therefore, we will write it with its +1 charge and as an aqueous ion because it has dissolved. We do the same thing for our nitrate. It has the -1 charge because it kept the electron and is also aqueous. Similarly, our sodium has kept its +1 charge and is aqueous. Our chlorine has kept the -1 charge and is aqueous. For our products, the silver 1 chloride is a solid. It is a precipitate. Because it forms a precipitate, it does not dissolve. It is insoluble. Therefore, we do not split up this molecule. It is a solid. It stays a solid. Because it is a solid, it is still bonded and does not get a charge. The sodium nitrate, however, is aqueous and it will split apart. This is our complete ionic equation. It has showed all of our dissolved ions and it has showed our precipitated ion, or our precipitated compound, excuse me. it's very important to include the aqueous or the solid, because we can look at this now and see what has precipitated and what has not. Net ionic equations only show the solid that is dissociating or the precipitate that has formed. If we look at our example, we can do this by identifying what our precipitate is. There's our solid, so this is our precipitate. Starting on the product side, because that's where our solid is, we are going to cross out anything that's not a precipitate, which would be our sodium and our nitrate. We are going to do this also on our reactant side. So looking for our sodium, it's crossed out, and looking for our nitrate, it gets crossed out. Those are crossed out because they are considered spectator ions. They are not creating the precipitate. Now we are going to rewrite our complete equation to form our net ionic equation, only including the ions that form the precipitate. We take our silver with the positive 1 charge as it is soluble, plus our chlorine with its negative 1 charge, and it is currently soluble. They react together to form our insoluble silver chloride solution, or silver chloride solid, which is our precipitate. At the top we have our complete equation, and at the bottom we have our net equation.